All right, welcome everybody. I'm very happy to see people here at 9 a.m. on the last day of the conference, so thank you for showing up. My name is Brian Dewey. I'm the Group Program Manager for Hyper-V in Windows, and I need to start with a little bit of a disclaimer. If you came here expecting to hear more about a grid control, or to hear, maybe how to do some cool new tricks in JavaScript, wrong session. I'm here today to talk about servers. Those things that actually do all of the business processing and handle the email and deliver the business data that make the tablets and laptops more than just toys. Servers, that's what we're going to talk about. In fact, maybe we should start with a round of applause for the unsung hero, the server. Now, this talk is part of a track that deals with the investments that we're making across Windows Server to deliver a strong continuous availability platform for our customers. So if you've been to other sessions in this track, you've actually probably seen demonstrations of Hyper-V features. If you've been to other server tracks or other server sessions throughout the conference, you've also probably seen Hyper-V features. And this is really just a reflection of the fact that for server workloads, virtualization is here to stay. And it's very difficult to talk about the next version of Windows Server and not talk about some aspect of Hyper-V or virtualization. So I will apologize if any of this material is information that you've heard before in other sessions. But the advantage that we're going to get today is we do have this opportunity to have one talk and have one Q&A period that will focus on Hyper-V and specifically the areas where Hyper-V helps contribute to the continuous availability platform, and specifically the areas where Hyper-V and the hardware interact. Move forward. So what we're going to talk about today is how Hyper-V completes the continuous availability platform in software. And really we're going to talk about how software and hardware can best work together to deliver continuous availability for customers. So we're going to learn about how Hyper-V takes advantage of new features that can come from storage, can come from the networking stack, and can come from the server chipset itself. And you're going to leave with examples of how you could design hardware or design solutions that help customers achieve continuously available Hyper-V deployments. Now, I've thrown out the term continuous availability a couple of times, and throughout the tracks about continuous availability, this is specifically what we're talking about. Getting software and hardware working together to provide transparent failover without data loss. So we're going to talk about what we, Microsoft, have been doing in the software and where, hopefully, you, the partners, can help on the hardware side to really achieve this vision. So let's talk a bit about the software side of things. What have we done in the next version of Hyper-V to help customers improve continuous availability? So the first thing that I want to talk about is live migration. Live migration is the ability to take a running VM and without service interruption, move it from one computer to another computer. Now, in Server 2008 R2, we introduced the ability to do live migration. But live migration was confined to migration between nodes of a cluster. In the next version of Windows, we're really setting the virtual machines free. You can migrate from any one computer to any other computer. It does not have to be confined within a cluster boundary. Now, things get even more powerful when you combine live migration with the next feature that I want to talk about, which is live storage migration, a feature that you saw demoed at the keynote on Wednesday. Storage migration gives us the ability to take any file that is associated with a virtual machine, the VHD files representing the virtual disks, the snapshot files, the configuration files, anything associated with that virtual machine, and while it is being used, move it from one location to another. Now, really quick at a high level, here's how that works. What we can do in the virtual machine, When you initiate a storage migration, we first do a copy behind the scenes, and we can copy the VHDs and the config files, etc., from any one location to any other location. We drive it from the top of the I/O stack. So we can move it from local attached storage to network storage. We can move it from an external storage array to a file server. It doesn't matter. As long as the storage is exposed as a file system, we can do that copy. Then, while the virtual machine is running, we take the I/O and we mirror it to both locations. Once we know that we have the destination copy in sync with the source copy, we can then flip a switch and have all subsequent I/Os just go to the destination copy. The storage has been moved, and there is no service interruption. Things get even more powerful because we can combine storage migration and live migration into a single operation for the user. It's a simple one checkbox in our UI, because what we are able to do by combining those operations is, first of all, from a customer scenario, it means that you can take any virtual machine running on any computer, and as long as I just have an Ethernet connection to some other computer, I can move that VM. We do it first by moving the storage, and then we do the live migration that existed in Server 2008 R2. And what we can do internally by combining those operations, I talked about how storage migration works. We do a copy, then we start mirroring the I/O. We stay in that state where I/O is being mirrored while the live migration happens. So we start copying the virtual machine memory state. Through what we call the brownout period, once we get the virtual machine appropriately in sync with its executing memory state, we enter the blackout period. We finally start executing the virtual machine on its target node, and then we can stop mirroring the I/O. That means that if there's any sort of failure anywhere along that path, we can just, we always had that executing virtual machine on the source, and we can just, back out and have the virtual machine continue to execute on the source, have its storage continue to be on the source. So we can combine those operations and get seamless movement from any one server to any other server. In terms of continuous availability, what this means for customers is that they have much greater flexibility to achieve transparent failover without data loss and without service interruption. If you need to do something like perform maintenance on a server, you now have the capability to move all of the executing virtual machines off that server, perform the maintenance, and move executing virtual machines back to the server, and people who are connected to the virtual machine do not see downtime. So that's the real benefit we get from providing this capability to customers and how it helps round out the continuous availability platform. So that's great if you need to perform maintenance on a server. What if you need to do maintenance on the virtual machine image itself? So I have some sort of service executing inside the virtual machine image, and I need to patch that VM image, for example. That's where customers traditionally have been turning to guest clustering. That's the ability to take two virtual machines, create a cluster between those virtual machines, and then, as needed, move an executing service from one virtual machine to another virtual machine. That's something that we supported in Server 2008 R2 if you used iSCSI storage to connect as shared storage between those virtual machines. What we're providing in the next version of Windows Server is the ability to connect virtual machines directly to Fibre Channel. And I'll talk a little bit more about that later on in the presentation. But this does give customers one more deployment option for creating a guest cluster of virtual machines. The final thing that I want to talk about that we've done in software to help with continuous availability is Hyper-V Replica. So Hyper-V Replica is new functionality in Windows Server 8 that helps customers maintain a warm standby virtual machine specifically targeted at the disaster recovery scenario. And here's how it works conceptually at a high level. You can go into Hyper-V Manager and go to any running virtual machine, right-click on that virtual machine, and initiate a replication relationship with a remote Hyper-V host. What we first have to do is perform an initial replication. That's get those VHDs, get the config files, etc., from the source where you're executing over to the destination. Then, once we've performed that initial replication, at periodic intervals, stepping back. Once we perform that initial replication and once we initiate the replication relationship, we keep track of the changes that are happening to the virtual machine. So once the initial replication has finished, at periodic intervals, we ship the changes from the source to the destination, maintaining a warm standby server on the destination. Now, we're optimizing this scenario for WANs and for disaster recovery. And let me tell you specifically how that pans out into the features. If you're trying to do replication over a WAN, so the link has high latency, maybe not great bandwidth, that initial replication, moving hundreds of gigabytes of VHD data, for instance, could take an incredibly long time over the WAN. So we've built in support for an out-of-band initial replication. If you need to, you can copy your VHDs to a USB hard drive, FedEx that USB hard drive to your remote site, and perform the initial replication that way. Then, since the subsequent replication is just sending changes, that should be able to work efficiently over the WAN. We also optimize for what I'll call loosely coupled relationships between the source server and the target server by supporting features, for instance, like certificate-based authentication. So the source and the destination don't have to be part of the same domain. They don't even necessarily have to be part of the same company. You could have another business that is providing disaster recovery capabilities, sign the contract, get the certificate, perform the certificate-based authentication. So we're targeting the WAN scenario, and we're targeting disaster recovery. The reason why I keep saying disaster recovery is the scenarios that we are going after with Hyper-V Replica are ones where the administrator initiates the failover. So you're aware that the hurricane is coming, or you're aware that the flooding will be happening. So the administrator initiates a failover to that warm standby system. So that's Hyper-V Replica. It's all new in Windows Server 8. It is all driven through software, and it does help round out the continuous availability platform. So this is this is actually, first of all, just scratching the features and scratching the surface of the features that we are providing in Hyper-V. And if I gave a, what's new on Hyper-V talk, it would need 90 minutes, and there's a lot of stuff to cover. But this is a high-level overview of what we're doing specifically that targets continuous availability. But I think the real interesting things to talk about are how the software features and the hardware features can work better together to deliver great solutions to customers. So one thing, everything that I've talked about so far is how Hyper-V helps deliver continuous availability. And we've seen more and more customers use Hyper-V as an important component for continuous availability solutions. And we are also hearing from the same customers that they are demanding continuous availability from the hardware that they are executing on. Because as you start putting more and more virtual machines on a single host, the impact of failure to that host is magnified. Now, there are several things that you can do to build the right continuously available platforms for Hyper-V. And I'm going to talk about features that the hardware can expose through storage, through the networking stack, and through the server hardware itself, and how those can be used by Hyper-V to help to deliver a great solution to customers. Let's talk first about storage. Continuously available platforms for Windows Server require shared storage. Now, in Windows Server 2008 R2, the one way you could get shared storage that would work with Hyper-V is through external storage arrays. Those continue to work in Windows Server 8, but there are going to be some improvements that we'll talk about later. The important thing to cover as well are the 3 new types of deployment scenarios that will be possible in Windows Server 8 to provide shared storage for Hyper-V for continuous availability. And we're going to talk about each of these. We will introduce the ability to use remote file servers for Hyper-V. We will introduce storage spaces, and that will be able to work with Hyper-V. And finally, clustered PCI RAID will work with Hyper-V. Across all of those storage types, you want to know about VHDX. This is a new file system or a new format that we are introducing for virtual hard disks to address some customer problems with existing VHD. The first customer problem is that you could only have 2 terabyte VHD files That was great when the VHD format was first designed. It's not so great for customers now. So the new VHD format supports, and we have tested up to 16 terabytes in the VHD. The second thing that's important is disks these days tend not to have sectors that are 512 bytes. So we have baked in support for large sector sizes into the new VHDX file format. So we do alignment on megabyte boundaries for all of the important I/O that we do and all of the metadata that we maintain so that you can get effective performance on large sector disks. Finally, customers want the ability to embed metadata into VHDs, and we had no supported way to do that in the existing format. So we have added the ability to put custom metadata into the VHDX format to help make this more manageable and more useful to our customers. So VHDX works across all of the storage deployment scenarios that I'm going to talk about next, and it's going to be something that will be very important for customers in the future. It is also going to be the default format for VHD files moving forward, so Windows Server 8 and beyond. So let's talk about external storage arrays. External storage arrays were supported in Windows Server 2008 R2. It was the one way that you could get shared storage that would work for continuous availability for Hyper-V. Customers would deploy the clustered shared volume software to make sure that all Hyper-V hosts would have access to the VHD files that were stored on the external storage array. And this deployment scenario continues to work in Windows Server 8. But it gets better in two important ways. The first one I already alluded to, which is we are providing the ability to connect virtual machines directly to the Fibre Channel network. Now, the way this will work at a high level is you will be able to go into a virtual machine and create a virtual host bus adapter, make that part of the virtual machine configuration, and then you can connect that virtual HBA directly to your Fibre Channel network. Each virtual HBA that we provide into the guest will get 2 worldwide port names. You can zone your LUNs directly to the worldwide port names that are associated with that virtual machine. And the one great benefit for customers then is that as that virtual machine migrates from host to host that's connected to your external storage array, all of the security settings should continue to work because it's still connecting with the worldwide port names associated with that virtual machine, even as it moves from host to host. The second important advancement in using external storage arrays would be if the external storage array supports offloaded data transfer or TRIM. And these will be able to work with Hyper-V scenarios as well. So to give you a little more information about how ODX and TRIM work, I would like you to welcome Senthil Rajaram, a program manager in the Hyper-V team. He will do a quick demo.
Hey, guys. So how many of you, sorry about that. How many of you guys actually attended Rajiv Nagar's platform storage evolution talk? Did you notice that he had put an R in front, revolution? That's exactly what we're talking about in this. So I'm going to be specifically focusing on ODX, and he had a pretty compelling demo in his talk where he demonstrated offloaded data transfers. What I'm going to be talking about is how this integrates into the virtualization scenarios and solves key virtualization problems and helps existing virtualization scenarios. So just to quickly recap on what offloaded data transfer is the fact that forever now you've had this traditional copy model where the computer, if it had to do a copy, would go down to the source, read the data, get it into the computer's buffer, and then push it down to the destination stack, right? Simple. Except for the fact that the computer had to spend significant amount of CPU as well as system buffer to hold this data and move it around. Now, all this is fine for, JBODs and this like disk, but for external storage arrays, which has got like these really high-end controller systems sitting there waiting for somehow to make more work happen, right? And this is what we talked about. So we talked with our hardware partners. We said, how can we leverage that processing power out there in the storage controllers? So we moved and tweaked this existing traditional copy model to a more token-based mechanism where a lot of the processing is actually done by the I/O controllers. So going back to the traditional model, we go do the read, and instead of getting the data buffer back, what we get is a token that represents the data. Simple. We take that, and we go down to the destination side, right? We shove that token down to the array, and if the disks are sitting in the same array, the token representation is used by the array to move the data from the source to the destination. We have just cut down significant CPU as well as buffer requirements on the host. And this is important in virtualization scenarios, right? The CPU and the memory is actually what's required for scale, hosting a large number of VMs and all those good things. So it definitely helps scenario. Again, like I'm going to be talking about doing a couple of demos which talk about how these tie into the virtual storage stack. There it is. So the first demo that I'm going to talk about is to drive across the point that this is just not the copy scenario. Right? How many of you here have tried to create a fixed VHD? Let's say 10 gigabyte. How many had to twiddle your thumbs? Right? So what we're going to show you is the same scenario, except that it's going to be on a copy offloaded backend system, right? What I have here is a copy offloaded disk, and I'm creating a 10 gigabyte virtual hard disk of the fixed VHDX format, all right? Let's kick this off. Usually, you would expect this to take about like 5 to 6 minutes. But don't blink. This is where it gets interesting. It's just done, just like that, right? It's almost done, and you can see it's. And this is not some shenanigans that's happening on the host system. This is a fully allocated, completely zeroed out fixed VHDX that's there. That took less than 10 seconds. You're going to say that, Senthil, come on, man, that's still on the host. Where's the virtualization meat, right? What I'm going to do now is switch over to 2 VMs, right? On the left, you have the traditional storage stack with copy offloaded turned off. And on the right, you have the copy offload turned on. And I'm going to perform the same experiment. I'm going to kick off the off because obviously that's going to take a little bit more time. And the same 10 gigabytes, I'm going to do it on the other side. And you can see that it's already blazing by. So what's happening here is that it's just not copy. What we have defined as special tokens, and in this case, the special token is a 0 token, where any application can communicate down to the storage stack that, look, I'm interested in making sure that these blocks are zeros. Instead of me spending all that time trying to create buffers, filling it with zeros, and sending it down, go make it happen. It's the same contract. You know, when the storage array completes it, it's got to give us the same contract that whenever I try to access any blocks of that range, it's going to give me a 0. It's done. This is still waiting at, 20%. So I'll let it run. It's got quirks about canceling it. The next point that I want to drive across is the fact that it's just not limited to local stack, right? With Hyper-V over SMB and SMB 2.2 enhancements, we expect a lot of these customers to be using SMB file shares to access data, to deploy, and a whole other things. What I'm going to show you is the fact that the copy offload semantics have been plumbed right through the storage stack. And if you have the same array that's exposing the file share as the same array that's hosting the disk, you can provide copy offloads across these. Right? That's powerful if you think about it. And I'm going to use this demo to illustrate that. So I have a share here that's visible to both these VMs. And I have a huge file that I'm going to copy to the local virtual disk associated with that VM. So this has got a fixed VHDX backing it but sitting on a different volume on the same offload-capable hardware as the one that's being surfaced by the file share. So the file share is actually backed by a different volume on the same offload-capable hardware. And in future, you could think about this as being disjoint or geo, in different geographic locations. And as long as they can talk underneath, we're still golden. So here, I'm going to initiate the copy on the offload where the VM doesn't have the offload support. And then I'm going to initiate it on the one which does have the offload support. And what you can see here is that there's absolutely there's no network data activity going on here. But in this case, there's definitely a spike where data is being moved around. And as you can see, I'm just trying to get the speed details. Whoops, that was a one. OK. Sorry about that. But you can see it's like hitting almost 100 megabytes per second, whereas the other thing would have been like literally maybe 20, 30 megabytes a second. What I want to drive across the point is the fact that copy offload, just by its very semantics, helps with large data moments, right? And virtualization, just by its very nature, deals with these large files and large blocks of moments. And it plays right into our scenarios. There are other scenarios that I could have shown if demo time permitted, where we could have talked about how live storage migration actually completely uses this to move VHDs from one place to the other. Or merge, where you're moving significant chunks of data from the child hard disk to the parent. So it's completely integrated into the virtualization stack. If you have copy offload enabled hardware, we will make use of it. Thanks, Brian.
So while the ability to use Hyper-V with external storage arrays existed in Server 2008 R2, the value that customers will be able to get from external storage arrays is quite a bit larger in Windows Server 8. The functionality and value that partners can put into external storage arrays get really, as Senthil showed you, exposed all the way up the stack and can really benefit our customers. Now, Senthil talked about Hyper-V and SMB, and that's the second major deployment scenario that I want to talk about. Oh, yeah, you saw the demo. Hyper-V in Windows Server 8 is going to add support for remote file servers. Now, this is something where I've had conversations with customers in the past because we didn't block putting a VHD file on a SMB file server in Windows Server 2008 R2. So some customers tried it. Seemed to work, so they'd say, hey, how come this is not a supported configuration? And it's really because the end-to-end scenario that customers need to run, in particular, to run a continuously available Hyper-V deployment, the end-to-end scenario didn't work in Windows Server 2008 R2. So I'm very happy at the work that has been done across Windows Server to make sure that deploying Hyper-V against a file server backend is a fully supported scenario that makes a lot of the end-to-end features work. So in particular, problems that you would have if you tried to deploy Server 2008 R2 with a file server, there was no way to make that backend continuously available from a Hyper-V perspective. If you clustered the backend, when a cluster failover happened, the handles that we would have on Hyper-V would no longer work. So that would appear to be a service interruption from the customer's perspective. The performance that we could get out of the SMB protocol was not as good as what people could get through some of the other protocols. And finally, we had no way to integrate host-based backup with an SMB deployment. And we've made improvements in all of those areas in Windows Server 8 to really make this scenario shine and be a first-class citizen. So with the new SMB protocol, SMB 2.2, you will have the ability to cluster the backend cluster your file server, and if a cluster failover happens, from the perspective of the Hyper-V host, our handles will remain valid and we can continue to do I/O to the clustered file server and have everything continue to work. So we now have a high availability deployment that works with file servers. There have been a ton of improvements in the SMB protocol to take advantage of new hardware like RDMA, and to use multiple channels to deliver just amazing performance in the SMB scenario. And finally, in Windows Server 8, they are adding support for remote VSS. So if you are using a file server backend, you can still do host-based backup and get application-consistent backups of all of the virtual machines that are running. So the end-to-end scenario now works. And we really expect this to be a very common customer deployment moving forward. Now, an important thing to note is that file server needs storage. That's what it serves out. So everything that we've talked about in terms of external storage arrays, if that's what you want to connect to your file server, that will work. As Senthil demonstrated, if that external storage array supports copy offload, that value goes all the way up the stack into the Hyper-V scenarios. So you have a lot of flexibility in how you set up and manage your file server. And because of the work that's been done for performance, the work that's been done for availability, and the work that's been done for manageability through backup, the customers can get a great end-to-end experience. An important thing to note about the scenario, and one of the reasons why we think it is going to be so important for customers, is if you want to do live migration across clusters, you need to be using SMB storage as your backend. So external storage arrays are great, but external storage arrays requires the cluster software to arbitrate access to the LUNs. So if you're using an external storage array, those virtual machines that you're migrating need to be part of the same cluster. If you're migrating across clusters, you will be using a file server somewhere in the picture, even if it's only transient. A different way that you can provide storage capabilities to either directly to Hyper-V or to a file server is to set up what is known as storage spaces. So this was covered in more detail in Rajiv Nagar's Storage Platform Evolved talk. The important things to take away in terms of storage spaces is that it is an in-box software solution that provides pooling of storage, thin provisioning of storage, and resiliency. And it is something that can work over a simple shared SAS JBOD. So this is something that customers can either connect directly to Hyper-V, and then set up the cluster service and use CSV, and really it can be, in that case, analogous to using an external storage array. Or this could be the way that you provide the storage in your file server. So both deployment scenarios would work for customers. And the last way that we can provide shared storage is through clustered PCI RAID. And this is extending the hardware RAID to be continuously available in a cluster. So this will provide resiliency to node failure and resiliency to disk failure. And it will provide customers a solution that will work at smaller scales than what you could get potentially from an external storage array, but can potentially at a lower cost point. So when you compare Windows Server 2008 R2 with what we're providing in Windows Server 8, there are many, many more deployment options that customers will have to get shared storage and have a solution that provides continuous availability. At the networking stack, there are a couple of important innovations that I want to talk about that specifically relate to continuous availability. Again, there's a ton of stuff that's happening in Hyper-V networking, way more than we could cover in this talk. And there have been several other talks that have dealt into things like the extensible virtual switch, etc. I want to talk specifically about the things that are coming that help with continuous availability and with scale. So the most important thing is that we will support in the box in Windows Server 8 NIC teaming. So if you're building solutions for customers, make sure there are multiple NICs in the box. NIC teaming from a Hyper-V deployment perspective will work either in the root or in the guest. So you could take, in the diagram that we have on the left, this is the case where you're doing the NIC teaming in the guest. So you provide 2 physical NICs in the parent, 2 virtual switches that turn into 2 virtual NICs in the guest, and that get teamed in the guest. The diagram on the right is the teams created in the parent. There's one virtual switch in the parent, and the virtual NIC is exposed up to the guest. Both of those scenarios work, and again, customers will have a lot of flexibility. We're also doing a lot of work specifically around scalability that will impact continuously available deployments as well. So the first thing, actually, and I forgot to mention it earlier, an important live migration improvement that we have added in Windows Server 8 is the ability to do multiple concurrent live migrations. And this does mean we would love as much bandwidth as we can get out of Hyper-V hosts. So designing systems that support and have in them 10 gigabit networking, that's great. We can use that bandwidth, in particular for common customer scenarios like node evacuation. So I have a host. It has 30 virtual machines on it. I need to perform maintenance on that host. Through multiple concurrent live migrations and 10 gigabit networking, it's going to be much faster to get those virtual machines off that host. Hyper-V deployments will also benefit greatly from RDMA. Now, RDMA, the benefit is on the parent side, so the root partition of the Hyper-V host, and the real benefit that we will get from it is speed up through the SMB protocol. RDMA is not something that we can expose directly into a Hyper-V guest. There are a lot of network offloads that Hyper-V hosts can use. One that I want to talk about specifically is SRIOV. So Hyper-V can utilize SRIOV-capable NICs. What this will provide for customers, for those who are not familiar with what SRIOV is, it means that a NIC, in addition to the physical functions that it exposes to the operating system, you can create and manage what are known as virtual functions. And virtual functions can be assigned directly to a Hyper-V guest operating system. When the Hyper-V guest then performs network I/O, it's going to talk to the virtual function, and that will talk directly to the NIC and go straight out on the wire. That stands in stark contrast with the way that most networking I/O has to happen today. Not most, all networking I/O has to happen today on Windows Server 2008 R2, where when you want to send a packet over the network, we have to send it over to the parent operating system, which then sends it out on the wire. The impact to the customer is network I/O from the guest will consume significantly less CPU than it does in a configuration that does not use SRIOV. So this, I think, will be important in more high-end scenarios where you're trying to drive as much networking as possible as you, into the guest. I do want to point out one potential disadvantage that SRIOV has, which is any of the manageability hooks that you're trying to build into the virtual switch. So if you went to the extensible virtual switch talk, since the IOV networking is going straight to the NIC, it's bypassing the virtual switch and would bypass any management functionality that's being added to the virtual switch. One last important thing to note about our implementation of SRIOV is that we have made it fully compatible with live migration. So you can live migrate a virtual machine even if it is using SRIOV and talking directly to a NIC. And the way we do that is we create, when you're using SRIOV, a network team in the guest. And we are teaming that SRIOV path with a pure software path. When we start a live migration, we fail over the traffic to the software path. Once it's going purely through software, we can then live migrate the virtual machine. Once the virtual machine is running on its destination, if that destination has an SRIOV-capable NIC, we can then connect the virtual machine back to the NIC, and once again, the traffic will go straight to the hardware. So SRIOV can deliver great scalability benefits, can lower the CPU usage, and it is still fully compatible with live migration, which is an important part of why customers use virtualization for continuous availability. Now, the last thing that I want to talk about before you get to see another cool demo that's going to pull everything together is how Hyper-V uses modern server hardware. So in terms of scalability, we've really upped what we are going to be able to support in the host. You may recall that today we will support up to 64 logical processors. So those are cores plus hyperthreads. We will support up to 160 in Windows Server 8. In terms of scalability of the virtual machine, if you're trying to create a virtual machine with lots of processors and lots of memory, one of the things that we will do when you create that virtual machine is actually project a NUMA topology into the guest. Because if you are trying to allocate, 128 gigabytes of RAM into a Hyper-V guest, that's not all going to come out of a single uniform access memory node. It's going to come out of multiple memory nodes, and we will provide the information to the guest so it knows how the memory nodes are laid out. And consequently, if you are running a workload like SQL Server that knows how to optimize its performance and optimize how it is doing its operations for non-uniform memory access, it will perform significantly better in the virtual machine because we are projecting the NUMA topology into the guest. So this really helps us achieve a scenario that we think of internally of large, high-performance virtual machines. The last thing that I want to talk about is fault containment. So some x64 processors are now being designed that let software participate in the error detection and error recovery process. And we are going to take advantage of that in Windows Server 8 so that if the hardware detects a memory error, so I can no longer read valid memory from address blah, 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 we can participate in the error recovery from that memory error. And specifically what we will do is if we detect that that memory error is in memory that belongs to a virtual machine, we can shut just that virtual machine down, as opposed to needing to take down the entire host and all the virtual machines on that host. Now, this is not going to be bulletproof for all memory errors, because if the memory error is in kernel memory or in the parent partition's memory, if you get an unrecoverable memory error, that will still take down the host. But if you've got a host where you're trying to keep a minimum footprint for the parent and you're dedicating most of the memory on that host to virtual machines, a memory error in that VM will take down just that VM. So we've talked about a lot of different storage configurations that you can provide for continuous availability, about some of the networking hardware features that can contribute to continuous availability, and also how we can use modern server hardware for continuous availability. And basically, I've been up here now for 10 or 15 minutes just going blah, blah, blah. I think you want to see more stuff. So please welcome up Jose Barreto, who will do another demo of Hyper-V over SMB2. You'll see RDMA, you'll see transparent failover. Great stuff.
All right. Thank you, Brian.
You want the next slide?
Yes, please. So we're going to do a little demo here. And the idea is just a moment. Let me get this started here. OK. So what we're going to show here is a demo configuration where we have, up on the screen, we have 2 file servers. We have 2 Hyper-V boxes, you have multiple switches, you have multiple I/O modules, and you're saying, wow, everything in this slide shows twice, right? That's exactly the basis of continuous availability. You introduce redundancy in the system. You have multiple of each, multiple disks, multiple connections, multiple servers, and essentially when something fails, you can transparently move over to the other resource that is surviving that configuration. And the whole idea is to do that without having any service interruption, right? So what we're trying to do here is be continuously available and have all this happen with industry standard hardware so that you can create your own solutions. Specifically in this case, I'm using JBODs connected to the file servers. Of course, if I'm using JBODs connected there, I'm using storage spaces as in this case, cluster storage spaces as my storage stack. And then it goes up to the file server, and then you have SMB, and then you go to Hyper-V on the other side. And we're using 2 clusters, 1 file server cluster and 1 Hyper-V cluster. OK? So let me switch over here to my demo box. Thank you. I got the wrong button. OK, so what we have here is the configuration of my file server. So you see here I have 4 boxes that I can connect to. I'm right now on my file server. So this file server, as I mentioned, is in a cluster configuration. So what you can see here is I have 2 nodes in my cluster. I have what I call file 3 and file 4, right? and say, where's file 1, file 2? And those are the demo systems that we use for the keynote on Wednesday, right? So those were standalone. This one now is a cluster. You also see that we have multiple network interfaces that we're using. So you see there, and we have 2 of them that are RDMA capable. So that's what we're doing. And also, if you look over here, you see that I have my file server resource. So when we're doing file server clusters, what we essentially do is instead of using the name of the nodes as the path that you go to access your files, you actually create this cluster name, which is essentially, in our case, what we call there file 5. So file 5 is actually not a physical box. It's a cluster network name. It's mapped to the specific resources that I have there. I have a few IP addresses. I have a few disks. And you see that I have there a couple of disks. One of them is nearly full. That's why it shows in a different color. And the other one has a little bit more free space, and I'm sharing those on the network, right? Now, I'm doing a lot of GUI, and we did a lot of GUI in the keynote, but I also wanted to reinforce the notion that we are capable of managing this system through PowerShell. And I wanted to quickly kind of mimic the details of the configuration that we had there and show you that we have PowerShell commandlets that you can use to inspect the storage configuration, to inspect the file share configuration, to inspect your network configuration. So we could be doing this through the Failover Cluster Manager in a graphical interface, locally in the server, but most likely you'd be doing this remotely. We could also do this from PowerShell. And one item that I'd like to reinforce here is when we are doing our access configuration, when using a file share with Hyper-V. So when you're doing this configuration in a regular external storage array, you essentially have to deal with things like worldwide names, LUN masking, all these things. Or if it's iSCSI, you have to configure IQNs or IP addresses or things of that nature. In the file share scenario, what we do is we grant access to the machines that are running Hyper-V. So if you look there in our get SMB share access, for the specific share that I created, I have granted access to the administrator so that it can be managed through the administrator console. And I also granted access to HV3 and HV4, which are the names of my Hyper-V nodes. So this way, these Hyper-V machines can go in and access the file share. And this is done through the regular tools that we use to create shares, to grant access to shares. Just in this case, instead of granting access to user accounts, you're granting access to computer accounts instead. All right. Oh, and one more thing. Down here in the configuration of your network, you can see that I have multiple network interfaces. Some of them are traditional gigabit Ethernet. Some of them are RDMA. And we showcasing our SMB 2.2 multi-channel feature, which essentially looks at that configuration, understands it. So if you see there, the bottom commandlet there is basically saying, oh, for this resource, I see that you have 3 different NICs that I can use. 2 of them are actually RDMA capable and have this much speed. So SMB is going to automatically use the best network configuration. You don't have to configure it to use this or that network. It's going to query the configuration you have on the server, match with configuration on the client, and make a selection for you. Right? And because we have 2, it's going to use them both. So what you get out of this is you have the ability now to be running here a few VMs. So these, now I switch over to the Hyper-V side. And what you have now is a Hyper-V host that has a few VMs running. Right? So what I'm doing here is, for instance, for this VM, if I look at the settings, you're going to see that a specific VM can use both local and file share storage now. This one, if you look here, we are storing this VHD file for the VM in the file share that we described in the configuration there. So you have to see how this goes. So you have the VM on this side. Inside the VM, it thinks it's using a disk. But actually, this disk lives in a VHD file. This VHD file is sitting on a file share, right? The file share travels over to the other side through a couple of high-speed network interfaces. Then on the other side, on the file share, it's actually not a physical file share, it's a cluster file share that we can move around. And that file share is hosted by storage spaces, which is going to the physical JBODs on the other side. Okay? So if you're familiar with virtualization, you understand what we're doing here, right? We're virtualizing the storage, and we're providing something that's flexible. You can move it around, right? So if you're running on one node, you can move to the other node. If you want to storage migrate, to live storage migrate from this file server to another file server, you can do that as well, as Brian was describing before. I am also going to take a look inside this VM. So what this VM is doing, what this VM is doing is we have here the VM running, and it's doing some SQL simulation here. So we have a tool that we use to simulate large IOs from the VM. So this tool is running inside that VM that I described to you. And as it's running, it's writing as much data as it can through that stack that I described, right? And what I wanted to show you, and I kind of spoiled it a little bit because I had Perfmon running all along, is we are actually doing all that I/O, and I'm inspecting the I/O from our new SMB 2.2 performance monitor in the parent partition, right? So what we're doing here, if you look at the perf, we're doing an average of 2.6 gigabytes per second through that stack, right? So the stack that I described, end to end, what we're doing, we're pumping 2.6 gigabytes per second. So just keep it in perspective, right? A 1 gigabit network can do what? 100, 110 megabytes. If you have a 10 gigabit Ethernet, you can probably do, if you're at line speed, 1.1 gigabyte per second. If you had fiber channel, you can probably do the calculation how much you can. We're doing this at 2.2 gigabytes per second. The reason we can do this is essentially, all right. The reason we can do this is because we are actually leveraging high-speed NICs. Not only one high-speed NIC, we're doing that with 2 high-speed NICs. So that gives us higher throughput. It also gives us fault tolerance. If we lose one, we can continue to work. That is being done by SMB2 multi-channel. The other thing that's happening is we're offloading this ability to transfer data to the CPUs in the NIC. So it is not the networking stack that's moving this data up from here, down to here, down to here. We essentially tell one side, hey, you are RDMA. Yes, I'm RDMA. Are you RDMA? Yes, I am. So they go negotiate, and they say, oh, I need to transfer this large amount of data. Instead of actually going through the regular stack, we do remote direct memory access. And one server talks to the client, and they do the transfer that way. That means we get low CPU utilization, we get very low latency, and we get these high throughputs, okay? Now, I'm going to try something here, and we all know that this is pre-release software, right? I'm just going to set the stage here, because what I'm going to try to do here, I have 2 file server nodes, right? Obviously, we're hitting one of it, or one of the 2. So what I'm going to do, I'm going to make this resource move from one file server to the other file server, okay? So in the past, if you did this kind of failover, as we were talking about, we would lose access for a little bit, but that's enough for Hyper-V to say, hey, I don't have access anymore, I can't do this, right? Now what we're doing, we're saying, when we do this move, we're actually going to say, in the client, we're going to say, hey, there's an I/O going, but it's going to take a while, but that's okay, right? And then, after we are active on the other node, we're just going to say, here's your I/O is completed. And then that's it. That's all the application needs to know. Something took a little too long. Okay? What I want to show here also is that I can do PowerShell. So PowerShell for Hyper-V as well as PowerShell for SMB, and both of them together. So one thing that I want to show you is that I can get that same list of VMs that I had before. I can get it from PowerShell. I can also go inspect the configuration of that VM. So what it's going to do is query which VHD files are inside that VM. And I can also inspect my connection settings. So I can see that I'm using those 3 VHD files on the file share, and I have a couple of RDMA interfaces being used. So we're using some commandlets from Hyper-V side, some commandlets from the file server side here. And now I'm going to go and import the failover cluster module, and I'm going to do the move. So I could go back to the cluster machine and do the move there. I'm going to do the move from my client because I can obviously remote. So you guys ready? Let's go. So what you see there is what we expect, right? So the I/O was happening there, and now it drops. Now the VM's still running. If I go look at my VM, the VM's there. What's happening right now is we're getting the other side to actually go and say, oh, I want to go, and then it starts the connection again. So it's starting at 1 gig, because that's how we know the box, right? And now it reestablishes RDMA, and we're back online. So you see there are 2 things that happen here. One is we suspended the I/O for a little while and said, hey, Hyper-V, it's taking a little while. We wait for the file server going for the other node, and then the client says, oh, you're up on the other node. There's some very interesting things happening in the back to notify and all that. And then when we resume on the other end, we have to do our multi-channel discovery again. So what we do, we start with our traditional path, and then we negotiate, say, hey, you're up? Yes, I'm up. So tell me information about your network. While we're doing that, we're using the regular 1 gig NIC. Then after we're done with that, say, oh, you're using RDMA. How about we go RDMA? And then they go RDMA. And that takes a couple seconds, right? What happens there is basically this automatic negotiation. And this happens as we move the resources around, okay? So I wanted to show one more thing. So that is continuously available file services at very high speeds, very low latency, low CPU utilization, right? Now let's do one more thing, which is to show you that in this case, we also want high availability on the Hyper-V side, right? So we have a highly available file share. We also want to have highly available virtual machines. Right? The way we did that in the past was you have to have the storage in an external storage array, because that requires cluster, and cluster requires an external storage array. Now, what you can do is you can do as I'm doing here. So I have my second cluster, which is essentially a couple of Hyper-V boxes, right? And these Hyper-V boxes are in a cluster as you would expect. So there's the cluster node names, HV3, HV4. And I have my cluster, which is called HC1, the Hyper-V cluster 1, right? And you see that I have a VM running here as well. But the important thing about this is when you go look at the settings for this VM, this is a highly available VM in a cluster, right? And you see that here as well, I am using a file share. So highly available VMs also using SMB for storage. And over here, when you look at the configuration, when you look at the storage, we're not using any disks, right? we're using just file share. So there's no storage resource, specific disk, physical disk resources here. Our storage is all done with file shares. Of course, you need to have a file share witness as well, which we do to get the third vote in the cluster, but that's all that we can do that today as well. So to review, we looked at how we have file server clusters that are continuously available, that are managed as regular file shares with echoes and permissions and shares as you are familiar with, right? We are also doing high-speed networking with RDMA with multiple connections simultaneously being automatically negotiated between the SMB client and the SMB server, right? And we also saw how we can use Hyper-V to store all data, all live data on those file shares, being able to do live migration to it with storage. Live migration from local storage, other types of storage. Also being able, we saw that in the keynote, if you remember that. And over here, we did the move from one node to the other node in the file server. And if we had more time, we could start moving things around within the cluster or between machines. And we also demoed that in the McNeil's Bill Lang's demo earlier on. We saw the move from between machines. So this is a flexible deployment. So you can build your private cloud with a lot of flexibility, easy to use, and because we're leveraging some of these technologies, reduce cost as well. I encourage you to come over. This setup is actually in the expo. So these physical computers are in the expo area. If you want to visit us after the talk, you're welcome to come over and we can talk more about it. Thank you.
So just a quick wrap up. I hope you guys are now excited and get an idea of the possibilities that now exist to have software, Hyper-V, and hardware work better together to deliver a great continuous availability platform for customers. There is a ton more of sessions to look at in terms of continuous availability, but the thing that I want to leave you with right now is please, please, please take the time to fill out session feedback. If you've got one of those nifty tablet computers here, type that URL in right now. We take the feedback very seriously. It helps us improve these presentations for future shows, so please do that. I'll also point out there's a bit of good-natured rivalry among the speakers, so if you liked the talk, definitely do the feedback. If you didn't like the talk, do the feedback, but say you liked it. So thank you all very much. You've been a great audience, and enjoy the rest of the show.